The broadcast is now starting. All attendees are in listen-only mode.
Yes, hi everybody. Welcome to our web seminar titled Wind Simulation with Ingrid Cloud. Thank you for your interest and taking your time despite your already busy working schedule. I also would like to thank Performance Network, the organizers, for giving us this opportunity. This seminar will last about 40 minutes, where I would like to focus on how architects and urban designers can assess the wind comfort for pedestrians, so using our platform called Ingrid Cloud. During my web seminar, I would like to address the following questions, and these are: why is wind analysis an increasing concern for the architecture, engineering, and construction industry? What every architect and urban designer need to know about wind simulations, and what Ingrid Cloud offers to accurately assess pedestrian comfort using computational fluid dynamics, which is often shortened to the acronym CFD. If you have any questions, you can leave them in our chat and we will answer them either after the presentation, during the presentation, and if there's not so much time left, we can also answer them in a blog post that everybody can access them later. So my name is Jeanette Spüler. I'm a CFD engineer at Ingrid Cloud. And Ingrid Cloud is a spin-off from KTH, the Royal Institute of Technology here in Stockholm. The core of our technology has been developed over a period of about 15 years in the research team led by Professor Johan Hoffmann, and I have been part of his team since about 10 years. In 2014, we were awarded with funding from the European Research Council with the aim to commercialize the technology, and Ingrid Cloud was founded in 2015. Our goal as a company is to offer a fully automated working process to simulate wind flow with high accuracy. But why is wind analysis an increasing concern in the architecture, engineering, and construction industry? And I listed 3 points as an answer. So firstly, more and more people are moving to cities, as we know, to find jobs and secure their living. So rapid urbanization coupled with increased urban density are some of the biggest contributing factors to pedestrian comfort and safety. So in 2015, the UN established 17 sustainable development goals, the so-called SDGs, towards 2030. And number 11 of these 17 SDGs aims towards making cities inclusive, safe, resilient, and sustainable. If you, as an architect and urban designer, want your building or a new part of a city to be sustainable and inclusive, so aligned with the goals of which were established by the UN, wind analysis will provide important information to assist your work and target. So, since this is an increasing concern to secure the comfort and safety for the citizens, regulations and requirements for wind assessment are in many cities, especially the ones with high-rise buildings or there might be known uncomfortable areas. These regulation requirements are already a reality. The one which is known and has been released last summer are the wind microclimate guidelines established by the City of London. And if you want to build new building in the core of London City, you need to follow these guidelines to get approved to be able to construct. So since this is an increasing concern, in some cities it's already a reality, and the tendency we can observe, there are more and more cities will require this from the architects. And the third point, so it's not only about security, but also the quantification of wind can improve the economical and social development of an area. Let's say you have a coffee shop, and this is regarding the wind safe, but it's still too windy to sit outside for a longer time, and this can affect your business. So a wind analysis provides also information of economical benefits. These are the reason why a wind analysis is an increasing concern for architects and urban designers. Here on this page, you can see some example of newspaper articles about cases in different cities where wind has accelerated and caused concern for pedestrians. So we have the famous case of Leeds. This is in the UK. I will talk about that a little bit later on. Another case is, for example, Ottawa. So in Ottawa, there was a proposal of 17-storied hotel, which was rejected actually by the city, since the planners believed the building would create adverse wind conditions and airflow problems. This was unusual and special, since this concern was raised in a very late stage of the project. Usually you do that earlier to save money. So the earlier such problems can be mitigated, desto better. And I would like to quote Isla Tanaka. She's a city planner in Edmonton, with whom we had a podcast. So she says, quote, "Wind is not necessarily an uncontrollable force of nature. Although wind can be quite complicated, we are not helpless before it, but we have to be much more proactive and plan for it." So the key is to be proactive, to plan, to predict the wind in order to secure comfortable wind for the citizens. So wind simulations are becoming less of an optional analysis, but more of a designing optimization tool, you can say. However, fluid flow simulations are not exactly a simple task. It's very a multidisciplinary field involving physics, mathematics, and also engineering concepts. But this shouldn't discourage you. And actually, this is why we have this web seminar, right? So that we can explain to you what you should know to run wind simulation with confidence, being an architect or being an urban planner, and get accurate results you want for your work. And now in this part of this web seminar, I would like to talk about some aspects you should consider when choosing your workflow for wind simulation. So there are points you need to know if you want to work with wind simulations. So first, when designing a new building, you need to understand how your choice can affect the surrounding, especially when you build a tall building and you want to be proactive, as Isa just said. So you want to predict it. A famous example is the Bridgewater Place in Leeds. This is UK. So here in the middle of the model, you can see the tower. It has a height of about 150 meters, and it's quite higher than its surrounding. This is a surrounding of about 500 meters. And unfortunately, this building created such strong wind that the safety of the pedestrians was endangered, so that the owners agreed to pay a huge amount to cover the cost, which was spent to build mitigations, as you can see on the right-hand side. So the blue arrow is the wind flow, and the green area, which is colored, are the mitigations. So to catch the wind from above, you could set up canopies, panels, and also wind catchers. So these are an illustration, and here on this figure, you can see how it looks in reality. So this can cost a lot of money for the owner, but this could have been avoided if you would have predicted in advance. So when you look at the 4 directional windrows here on the right-hand side, you can see the wind in Leeds is mainly blowing from west. And now looking at the velocity magnitude as shown in figure 1, this is a slide on the pedestrian height. so about 1.75 meters, and this is the wind from the west. Yeah, so from here you can see already, just looking simply at the velocity magnitude, that the velocity is accelerating around the corner of the tower. So this is the red marked area. Also, you can see this in figure 2, these are streamlines, and streamlines are pathways of particles, and you can see how the wind from the west is interacting with the building. So it hits the facade, is pushed down and around the corner. Again, you would assume acceleration, but simple acceleration doesn't mean that it is uncomfortable, but it's at least an indication. So just simply looking at the wind from the west, you can, there's an indicator, maybe I should more look carefully into this area because there's acceleration. And then you can also do a full pedestrian comfort as shown in figure 3. With full, I mean, you not only consider the wind from the west, but you also include contribution from the wind from the south, in the north, from the other wind direction. You summarize all them together, and then you get kind of a heat map. I will explain the colors later on in the presentation, but just to show, if you would have done a full pedestrian evaluation, this area would have been marked as unsafe. So you could have predicted already. Yes, so another point you need to know, or it's good to know, as an architect, physical wind tunnels and expensive consultants are not your only options. So only recently has the architecture, engineering, and construction industry learned to take advantage of CFD. For years, CFD has mainly been used by mechanical engineers, or classical fields for CFD is the automotive industry when constructing cars or also airplanes. However, thanks to the newest development of algorithm and computing power, simulation tools are now available for everyone, not just for specialists. This means you can access your results through your local computer. As you can see, this is your laptop. You can access your results. This is a video of volume rendering. So you can access the results through your local computer while using the power of a supercomputer remotely. As you can see, these are rackets. So designers, architects, and urban planners can test aerodynamics of the design even at the earliest stage of the creative process. Okay, let's see how I can go further. Great. Wind simulation you can use not only for securing their comfort, but you can also use them as a testing tool, design tool, you can say. And like if you would listen to the feedback of the wind, this can help you to improve building performance and can give you valuable insight on design modification. I think you know it's very common in the designing process that you have different designs and you need to choose one. And then the information of wind can help you to choose the best one regarding the quantity of interest. In this case, it would be velocity. Here on this slide, you can see a case we have run with a customer. Model 1, this is the existing situation, and Model 2 and Model 3 are future scenarios. So the blue-colored buildings are the modification. So it's actually good to simulate the existing situation as well in order to identify precisely which wind effects are created by the new construction. Not only the future scenarios, but also existing. Then you can really precisely say what is added or what is modified by your design. And also, as you can see in these images, we included the surrounding. Recommended is about a radius of 300 to 400 up to 600 meters, and also you can include topology, which can be additional important factor which can influence your wind comfort. But it can depend on the case. It depends on the area of interest, the building of interest, and also goal of your analysis. Yes, so so you don't need to be a specialist there, but there is an important aspect when you choose your tool to do wind simulation. And here I would like to talk about accuracy. So here you can see two different videos. They are CFD simulations. And the accuracy level defines how close the computational simulation represents the real-life wind behavior. And different mathematical models generate different results. So here, this is the same flow, but you use a different mathematical model. And you can see the results are different. And not all simulations are accurate when analyzing complex movement of the wind. So traditionally, CFD softwares do not resolve the small scale of a turbulent wind flow in order to reduce the computational cost, as exemplified in this movie above. And this is called Raun's modeling, Reynolds number average simulation. As the name say, it's average. So because you had to, maybe it's not even a wish, you had to because of limited technology. This was the reality in the past. So you needed to average some parameters such that you get a solution, but you can see that the solution is smeared out, the velocity field is smeared out. However, nowadays, as I said, that there are advancements in computer science and mathematics that makes it possible to resolve the smaller scales of the turbulent flow. And this is a mathematical modeling called large eddy simulations, where smaller scales can be resolved. So both are CFD simulation, but depending on what kind of mathematical model you choose, you get more or less accurate results. And this can also depend what kind of results you're looking for. But since wind is turbulent, it's recommended, it's better to use LES. And this is one of the strengths of our platform compared to traditional CFD approaches, that we can use LES, so we can resolve the small scales and by doing high accuracy. So this is one aspect which is important when you choose a software for doing a wind simulation. What kind of accuracy level do you want, or basically you need? And then the last aspect is if you choose a software, please make sure that the software is constantly submitted to an extensive number of tests, research, and benchmark cases to ensure the validity of the software. On our homepage, you can find different benchmark cases where we validated our code against real measurement in wind tunnel tests. And also for each simulation you would run, the raw data can be downloaded such that the accuracy can be examined by the user. On this slide, this is an illustration of one of our benchmark cases. We compared our results run by the CFD software or our technology with data provided by the Tokyo Polytech University, which run this case in a wind tunnel. So this database is open source. On the left-hand side, you can see the wind tunnel results. This is a high-rise simple block where you can see the pressure distribution, windward and leeward. These are the data for the wind tunnel test. On the right-hand side, you can see our results, the pressure distribution, windward and leeward. And if we compare our pressures point-wise, we could achieve a correlation of over 99%. So before I proceed to the second part of second part of the web seminar, I just want to summarize what you need to know about wind simulations. So we talked about it's important that you are proactive to predict the wind in advance, that you can save money and also get the optimal design. There are alternatives alternatives to wind tunnels and consultants, which were maybe the traditional way. And wind simulation can not only be used to ensure safety, but also can be used as a designing tool. And you need to be aware of the accuracy level when you choose a CFD tool, and also make sure that the software you choose for your workflow is constantly validated. So now I'd like to proceed and go more into depth of the application we offer from Ingrid Cloud, and this application is especially done and customized for pedestrian wind comfort. So when you would run a pedestrian comfort analysis on our platform, you get the information about the meteorological data. That means you get information about the statistical distribution of wind speed and wind direction of the chosen location. You also get a comfort map as illustrated in the picture above. This comfort map gives you information how comfortable it is in a specific area to sit, to walk, and so on. And also you get information about the wind dynamic, and this is about how flow behaves around your architecture. Now a little bit more in details about meteorological data. Using our interface, you have two options. Either you can upload your own wind data or use our interface towards MeteoBlue. This is a Swiss science and technology company that offers wind data worldwide. Then the analysis is done for seasons and also for the whole year. You can choose a different number of directions. It can be 4, 8, 16, or 36. And in this example, you can see here, the user has chosen 4 directions so that the whole data is distributed into the direction of north, east, south, and west. Increasing the number of indirections would also increase your accuracy. So this person is maybe in the early phase of design, so it's made basically more to get basically understanding how the wind behaves around the design. And the core of this application are the comfort criteria. So comfort criteria quantifies the wind conditions for a pedestrian. They measure the percentage of exceedance of the wind speed during a defined time period for a pedestrian. That means on a height between 1.5 to 2 meters. You can choose the exact height by yourself. So there's a wide range of different wind comfort criteria, since they can differ in thresholds and also in activities. On the left-hand side, you can see the so-called Davenport-based criteria, and this one is more commonly used here in Scandinavia. And on the right-hand side, you can see the more famous London-based criteria. So for example, if you look at the London case, if you want to have an area which should be comfortable for sitting, the wind in this area should not exceed 2.5 meters for 5% of the time considered. Or maybe you have an area, it's okay if it blows a little bit more than 2.5 meters, 4 meters, because it's a bus stop, so you want it to be comfortable for standing. So in this area, the wind should not blow harder than 6 meters per second for 5% of the time. So these are comfort criteria. And then in the last category is the safety criteria. So if the wind blows stronger than 50 meters per second for this threshold, if this is exceeded, then this area is marked as unsafe, and mitigation has to be considered and implemented in order to ensure the safety of the pedestrians. We often are asked about the temperature. Although humidity, radiation, and temperature can affect how we experience wind, the wind comfort only considers the mechanical effects of the wind. That means the wind velocity. And now the last, so we talked about the data you can get, meteorological data, we talked about comfort criteria, and now I would like to play a short video regarding aerodynamic information. See? Yeah. Okay, great. Just got a break to drink some coffee. So, great. Yes, and now I would like to interactively show how our platform works by an example we have run for the financial district of London. So I would like to proceed to our homepage. This is the financial district of London, and we have modeled it and put it in our. Okay, let's see. So it's loading our homepage. Okay, what's that? I'm sorry. Maybe I can put here. No. Let me see. Okay. Oh, okay. To prevent. No. Okay. Maybe I can show you this one then later after. Oh, it's not working. I'm very sorry for that. But maybe after I've gone out of the full presentation view, I can use the link and show you interactively. Okay, let's see. So, well, let's go back to that one later on when I've done the presentation. And so I mainly talked about the wind comfort application, but we also have different application as wind load. This is especially customized for measuring the pressure on the surface of buildings. So interesting for structural engineers. And we're also working on a new app called Wind Score. And we will launch this app in the coming weeks, where in the early phase of a project, architects can upload different design options, so you can upload different models at the same time. And these models are compared and ranked according to the velocity. So you get a ranking, and then one of them is basically getting the highest score regarding the velocity in the area of interest. If you would be interested in testing our new app in its beta version, please get in contact with us by email. You can also leave your name or LinkedIn information in the chat of this webinar. And well, I would like to conclude with our strengths of Ingrid Cloud. Ingrid Cloud is different from traditional CFD wind simulation in the sense that transient simulation can be generated with accurate results for urban area analysis. Our approach is fast since the setup is done via an interface using a web browser, and the calculations are run on some of the European largest supercomputers remotely. So the evaluation time can be reduced from weeks to hours, and the whole working process from the pre-processing step, simulation with the mesh refinement and post-processing step for the evaluation and visualization is fully automated. And this would actually conclude my web seminar. I wanted to go to the question, but maybe we can try to open the web page I was not able to access. So let's see. Maybe I can get some help. Would that be so? No. Okay, let's see. Let's. Just trying to find the homepage. No, maybe can somebody of the panelists take over and show our case, and I can just comment while somebody else would go through the page. Let's see. Do you see anything?
Can you hear me, Jeanette?
Yes, I can hear you.
Do you want me to go to the homepage for you? Then just go through the homepage so that you can describe.
Yeah, exactly. So what do you see now, actually?
Just the basic window that you are the presenter, but nothing else.
Yes, okay. If you could take over, and if I could see the same thing, then I could comment on that one.
Arpan, is it possible to hand it over to me or Luma by any chance so that we can go to the homepage and show it?
Yeah, so to Rafat, correct?
Yeah.
Okay.
Thank you for the help and thank you for the patience. Yes, I can see your page. Perfect. Thank you.
Everyone else can see. So, Jeanette, I will go to mute. So you just let me know when I need to change anything. Okay?
Yes. Yeah, that's perfect. Thank you so much.
No
so
problem.
This is basically the result page. And now you can see the Rafat has his mouse over the model. So in the middle of the page, you can see the model which was used for the simulation. This is the financial district of London with an area, a radius of about 400 meters. Now, where you can see his mouse, this is the location where the weather data is fetched. You can see below the coordinates, the geological coordinates where the weather data was fetched. And here, these are the wind roses which were fetched for this simulation. You can see this simulation has been done with 8 directions. And also, as I said, the evaluation is done for each season and for the whole year. If we go a little bit more downwards, I would like to show the input parameters. So input parameters are the summary of the input parameters in order to start your simulation. In this case, the user has chosen an evolution height of 2 meters. We can choose also 1.75, 1.5 meter is the guidelines, for example, for London. As I said, the evaluation is done with 8 direction. And also you choose wind profiles. wind profiles are the curvature of the wind before it hits the model. Could you open that one? Yeah, exactly. Could you open the wind profiles? Just, yeah. So this is basically when before the wind hits the model, it goes over a certain domain, like it could be city, it could be open terrain, it could be lakes, and this would change the curvature of the wind. And this is called roughness parameter. It's a logarithmic wind profile, and we align with the standard of the US. So these are the parameters you have to define before starting your simulation. And solver parameters, they are more interesting for if you are a CFD expert. Now, this is the summary page. Then if you go upwards, Refat, if you could show us the wind comfort. Perfect, thank you. This is the core of the results. And as I said, you have two criteria, the Lawson and the Davenport criteria. We can also add other criteria if there are special ones for your city. But now let's go to the Lawson one. If you could open that one, great, thank you. So this is how it works. This is an interactive 3D viewer. So you can rotate, you can zoom in, and on the left-hand side, you can see the legend. So if you want to have an area which should be comfortable for sitting, then this area should be marked by dark blue colors. Maybe Rafat, could you zoom in to area which is dark blue? Yeah, exactly. On the right-hand side, beside the high-rise building, you see dark blue areas. So these areas are comfortable for sitting. Then you can choose different quarters, different seasons. If you could show the drop-down, Refat, thank you. Exactly. So you can choose second quarter. This is the season from April to June. This would be the spring, for example. You saw into the drop-down field. You can also choose the whole year, and also exactly. Thank you. And you can also, on the visualization, you can activate terraces and rooftops. So this is an interesting feature if you would be interested in an outdoor sitting on a terrace. And then you can activate it, not only the topography, but also the rooftops. And then zoom in, choose an angle of view which suits for you. And then you can actually take a screenshot. If you can see the camera on the left, exactly on the left-hand side. If you have a view which suits your need, you can take a screenshot and directly import this image in a report you need to deliver for your municipality, for example. Thank you. And let's close this interactive window. That's okay, thank you. So this is the core, right? This is the core of our application. You want to have a comfort map. And then let's say you have an area you're planning to have coffee. So the activity you're interested in is sitting. But unfortunately, your first design shows that this area is only comfortable for standings. So then you're thinking of, okay, I need some mitigation, but how and where should I put up mitigation? And then the second result, the wind effect, gives you information from where the wind flows in order for you to set up proper mitigations. And here for wind dynamics, we have three ways of visualization. So the first one is streamlines. These are pathways of wind particles. It's the same approach, interactive 3D viewers. And then this is the wind from the north. You can also choose different wind direction. Remember, this is a simulation with 8 directions, so you can choose a different direction. Yes, for example, east. And you will see streamlines from the east direction. You can step forward and in the volume. So if you exactly by the arrows, so you can streamlines are moved in the volume so that you can move them to the area of your interest. And these are vertical streamlines. You can also change the perspective, and you can choose horizontals, and then you can choose the arrows to move them upwards or downwards in height. Again, here you can choose to take a screenshot in the position of your interest to extract interesting dynamics. So this is a very usable tool, additional information to the pedestrian comfort. If we could close that one, thank you. You don't have to open the other ones. I just want to explain shortly. So this is the mean velocity. So this is one way of visualization, are the streamlines. Other ways are the magnitude of the velocity field, and they are either shown on the surface of the model or in slices in the volume, so that you get an understanding where high velocity magnitudes occurs. And if you go up here, so the overview, you have a mesh. Some people want to know how the model is meshed, so you can do the same thing for the meshing. You don't have to open that one. This is because it's very specific for CFD engineers, but some guidelines required this information because they want to know how fine the resolution is of the mesh in order to secure accuracy. So this would be the mesh which of the surface with which the simulation has been run. Thank you. We can close that one. And last but not least, I talked about accuracy, but also if you want to customize your visualization, the ones I showed you, these are created automatically. It gives you a very fast access and a way to write reports or get an understanding of your design or wind analysis. But sometimes, depending on your customer, they have specific interest or maybe a specific understanding of the evaluation, and then you want to or you need to specialize or like have a special visualization. And therefore, we offer to download the raw data in the form of format of VTUs. So this is the mean velocity field and also the Lawson and Davenport. For example, you want to change the colors, you want to zoom in, you want to extract a special area of interest. So this is basically our platform. This is all the results, and for every wind analysis you run on Ingrid Cloud, these are the results you can get. And you can also share this report with your customer, with your co-workers, that everybody has access to the same data or same results, exactly as we have done now. This is our link. You can share, paste, and copy, and the people involved can look at the same results. Yes, thank you so much, Refat. So this would actually conclude my presentation. I'm sorry for the technique, and let's see, maybe we can advance to some questions, and then I would like to conclude the whole web seminar. Let me see. Okay, so Aremi, should I answer the question? Let's see.
Yes, so there are some questions from some individuals, and they should be sent to you. Do you see them?
Yes, is the first one from Elena?
Yes.
Yeah. So I read out the question. So thank you very much for your question. Unfortunately, recently Meteo Blue decided not to be open, and you have to pay for historical data. What should we use then? I use Windfinder, but it's not so specific and has no the windows. Okay. When you use our platform for the moment, if you use wind analysis, wind comfort, pedestrian comfort, this is actually fetched through our interface and it's included in the price. So if you run a wind comfort simulation, this is included, so you don't have to pay for that. And there are other, if you want to upload your own data, there is also other cases like one building. I think there are other web pages where you can download typical yearly average data. But if you use the interface through us, then this weather data is included. I hope this answers her question. And then question 2 from Gonzalo, thank you very much. Hello, I would like to ask you if you take into account the stability of the atmospheric boundary layer or do you only simulate neutral cases? So thank you very much for the question. This is an interesting question. For the wind comfort, we don't include them. It's a neutral case, but we're going to implement them as a next step. And you also have seen our second application, the structure for the structure engineers, the application called wind load. And there we take into account the atmospheric boundary layers. Yes. Okay. Did I miss a question?
No,
These were the ones, right?
Yes, those were the only ones.
Okay, thank you. And if you have any further questions, of course, you can contact us later on. We are very happy to answer them. Yeah, wait, one more question. Okay. Thank you. Wally, how the software, okay, thank you very much. So I would like to read out the question, how the software select the optimum mesh size to resolve turbulence properly. And mesh statistics report also like orthogonality and skewness. Okay, well, I didn't go into much into the technical part in this presentation, but we use adaptive mesh. And this adaptive mesh is connected to a dual problem, connected to the incompressible Navier-Stokes equation. So when you look at the incompressible Navier-Stokes equation, you can derive a dual problem. And this dual problem can be connected to the quantity of interest, for example, drag. And then you can estimate the finite element method and functional analysis. So we can estimate it by the dual problem and the solution you have. And by refining the mesh properly, this means by refining the elements which contribute with the largest error, you can reduce the error in the quantity of your interest. So it's at an automatically adaptive mesh refinement. And mesh report of like orthogonality skewness, well, the mesh quality is ensured by the mesh algorithm you're using. And as I said, you can actually, if you want to have more control, you can actually download the mesh and have a proper view on the mesh if the mesh or simulation corresponds the accuracy you want to. Okay, thank you. We got another question from Gonzalo. Thank you. And this is a typical one. So can trees be included in the simulation? This is a classical question we receive. For the moment, no, but we are going to implement this after summer. No, we were a little bit reluctant or like waited to implement trees. Well, if we're going to implement them as a porous medium, because we were not reluctant, I would not say, but waited or like we were very more careful, because the standard or the recommendation is not to include tree because the research is limited, and it can also give misleading results because there are so many parameters you have to consider. There's the age, the height of the trunk, the leaflet density, and this can differ from season to season. And high velocity especially occurs in winter seasons when the trees doesn't have leaves. So even though you would have trees as a mitigation plan and it looks good, in winter the parameters would change. So, but since there is a need or a request from our customers, they're going to implement them, but we would like with caution. And yes, and also the guidelines from London actually recommend not to use. It's rather to take the conservative approach, not include trees, and as a worst case scenario. Yes. Good. Thank you so much for your questions. And if my answers were not very satisfying, we can still continue maybe the conversation by email or I don't know if by a one-to-one conversation. Okay. Should we close?
Thank you very much, Jeanette. Arpan, I guess you can take over now. Thank you very much, Jeanette, for your
If there are no more
presentation.
questions, we can wrap up this webinar. And if you want to put on the screen your contact information where people can reach out to you for more information.
Sure, we can do that. Doma Remy, can you just put the address over there in the contact?
Yeah, let me take a look here. Let's see. Just one moment, let's see. I'm not sure if I have, do I have presenter controls? Show this one.
Yes, now I see something.
Yes, now you're the present.
Okay, I believe our contact information is at the bottom here. No. Maybe I can just,
Maybe just pull up the website or something.
yeah, we can do that. Just one second. Okay, sorry, just give me one more second here. Yeah, perhaps I can just share this in the chat and I can share it with everyone.
Thank you.
So there's our contact page. And there should be a link and you can feel free to send us an email, or if you're interested about our new WinScore app, I know there were a few people interested in getting to know more. So we'll be in contact after the webinar.
That's great. If there's no other questions or comments, we can conclude today's webinar.
Perfect. Thank you.
Okay, thank you so much.
Okay, thank you, everyone. Have a nice day.
Okay, bye.
Bye.